Alright, now it's time to help our creepy tree-loving friend. So, what we know is the growth rate of the radius, which is equal to 1/16 3 plus sine x squared. And we also know the initial radius, which is 6. So, the three things we need to do is we need to find an expression for r of t using an integral. Then we need to plug in t for 3 and find what the radius is after 3 years. Then we need to find the growth rate of the cross-sectional area at t equals 3 years. And finally, we have to evaluate the integral of the cross-sectional area growth rate formula and interpret the results. Alright, first things first. So in order to find an expression for r of t, we find the integral from 0 to t of the radius growth rate function, and we add our initial value, which is 6. And so from there, when we want to find r is equal to r of 3, we plug 3 in for t, and we find that r of 3 is equal to 6.611 inches. Next, we have to find the growth rate of the cross-sectional area after 3 years. So, since we know these are circular cross areas, we know that the area equation is going to be a is equal to pi r squared. And since we know the radius is equal to r of t, we can plug that in and get pi times r of t squared. So in order to find the growth rate formula, we take the derivative of that function. We get a prime of t is equal to 2 pi rt r prime t. And since we know what r prime t is, we can plug that in. So we have a prime of t is equal to 2 prime rt times 3 plus sine of x squared over 16. And from there we can simplify that up, and once we have that, we can plug in 3 for t, and we get a prime of 3 is equal to pi r3 over 8 times 3 plus sine of 3 squared. So from that we can find that the growth rate after 3 years is equal to 8.858 centimeters squared per year. Finally, the integral of a prime of t from 0 to 3 is can be interpreted as a of t from 3 to 0. So we take a of 3 minus a of 0, and since we know that these are circular cross sections, we have pi times r of 3 squared minus pi of r of 0 squared. And we know what r of 3 is from earlier in the problem, and we know what r of 0 is because that's an initial value given. So we find that it is equal to 24.207 inches squared. And this expression represents the change in cross-sectional area from year 0 to year 3. Thanks for watching.